Ich heiße Yitzchok Gottlieb. Mein erster Lusche ist nicht Yiddish, aber ich rede Yiddish, ich hoffe so. Aber ich bin ein Programmer bei GoFlow Commerce. Ich mache das System bei Integraten mit eBay, Amazon, Buy.com, alle Channels, Inventory System, Order Management System, Warehouse System. Und ich bin ein Co-Founder von der New York Old.net Group. Was trefft sich in Manhattan jede Yiddish. Ich weiß nicht, meine so bekannt mit Old.net. So, ich will reden hand wegen Salad. Das ist ein geleint wegen Salad ein bisschen. Ein Tag gekriegt, weißt du? Okay, so ich will unheimlich du mit Object-Oriented Design Concepts. Das the basic Sachen wegen Object-Oriented Design. So, die erste Sache ist, so du Objects oder classes, objects and instance in a class. Und noch dann machst du das Information Hiding. So in Object-Oriented kannst du behalten certain Chalukim von the program. So do public, private, internal, protected. So private behaltest nur in the class. Allein kannst du haben access to them, nicht das ganze Programm, nicht kein functional Program, no, lass mal sagen, man nicht C-Sharp, oder andere Programm, was ist object-oriented, man nicht nur a Sach function, also a Sach Programs stehen, also basically the ganze code is no functions, und man rief, du a große main class, fünf main classes, man rief, und alles ist da. So du in object-oriented, man nutzt das aus, so du a Sach features. So information hiding, so do inheritance. So this is base classes. Nothing had some classes deriving from the base class. Nothing was the interfaces, was this has a service contract. Was the sucht as ich darf the information, but you will implement it. Doesn't make a difference who implements it. But I just need these few methods that you have to implement. And then you have polymorphism that works together with interfaces and inheritance that says that wherever I expect a certain interface or a base class, I should be able to provide a subclass from it or an implementation of the interface. So, what is Salad? So Salad is the five concepts, five main things. If you want to build application, a program that is maintainable and that is readable, so there's a few principles. So Salad is Arishatavis of Arishatavis. It stands for Arishatavis. So it's geschrieben geworden, it's collected geworden by Uncle Bob, the Robert Martin. And so Salad, the finne Sache mit Salad is the erste Sache is SRP. S stands for SRP, that's single responsibility principle. I'll explain soon all the things. So single responsibility principle, open close principle, Liskov substitution principle, interface segregation principle, and dependency inversion principle. This is the five principles in Salad. So, wer weiß, was this is? So a Swiss knife was basically Retzachans can altstehen. Aber ich weiß, wer kann du treffen etwas in der Messe, wenn man da so bin. So it's also wie eine große Class, wenn a paar tausend lines in code, a paar hundert lines in code, und da steffen der Function, der kickst out auf der List von Function, der probiert zu sich, und du kannst gut nicht treffen. So the principle was the main. The principle is as a class should have one and only one reason to change. Man soll bauen the classes in a Weg, als der Class allein soll nur ein Sibbe sich zu tauschen, soll nicht 20 Sachen. Also dit eine Sache kann man sehen, was tut sich dort, kann man es managen, kann man maintainen. Es sind 50 Sachen, jede kleine Tausch, was man darf tun, kann umkommen, als die ganze Programm wird unstable, wegen das gemacht du a Tausch, was 20 Sachen die in der Sohn. Also als es vermachten ein Class, it's easier to see what's going on, and you could make that class work as it has to be. So some of the things that it helps out. So this is on all of them basically, but it goes on the first one. It's more if you have everything in one. You have one class that's very small, only targeted for one small piece of code. It's more readable. It's less error prone because you can see what's going on. You're not doing 20 things. You can make it more robust, and it becomes testable. If someone does unit testing, they could test small pieces of code instead of trying to test a big class that has functions and stuff going to the database, and then it becomes not testable. So if you keep it small, then you can test every small part and make sure that every part works correctly, and it's maintainable. So I'll show a little code example. So the biggest. So this is an interface, some I modem interface. Basically, it's like the old modems. They call into a server, and whatever they can send information. So this violates single responsibility because it has basically two main responsibilities over here. One thing is calling, and the second part is sending and receiving. That doesn't have really anything connected. So that's one example of single responsibility principle. And this is a split up version. This divided into zwei Chalukim, so zwei interfaces. Eins the connection, was nimmt care from connecting to the server. Noch the data channel was nimmt care from sending and receiving data, and that's how you could divide it. So usually, if you send and receive data, the data is usually in about the same format, so it would go in a way together. If you're changing one of it, you would change the other class. If the way you send data, usually it changes the way you receive it also. So that's not a violation of single responsibility principle. I'll do another example.
Is it less than what's considered a single responsibility?
It should just have one reason to change. If there could be two reasons why you would change that code.
No, this is deciding what's considered a single reason.
That's one of the main questions on this topic, how you decide. But some things you can see clearly that it's two separate things, and some things.
So basically,
and
als het gesprek met de anders hebben betroffen, dan is ook niet deze dat ze getoast is, dat gebracht een base.
Ja, de sender
hoeveel zaken heb je gesprek? Nou, laten we ook naar de macht eindtijd.
That's something a different approach. Weil die ganze Roster mal etwas anders in ganzen rausdeleten und das nach alt kennen jetzt ein andere Code, andere Sachen werden dort werden.
Oh.
And the can't divide in this water. Jetzt mach a separate method for send, a separate class for send, a separate class for receive. Aber noch dem wär's schon zu viel classes. Darf ich nehmen auch nicht zu viel. Darf den genug zu dividen, aber nicht zu viel, so mamisch werden on mamisch too much. Es ist nicht violate, man darf sehen, was heißt a violation und was nicht. Es ist doch mal gleich, was heißt a violation, aber
so basically it's more art than science. You have to make a judgment call.
Yeah, that's everything in programming goes like that. Here's another example of there's a shape class that does two things. It has the area, whatever it does, it's a string now, and it has a draw function. So it does it. Let's say implementation from that is the rectangle has the area, he returns rectangle, and draw, he draws it. Let's say hit to the console, but let's say to the window, same thing. But if you see over here, there's two responsibilities in the class. There's first of all the area, how you create a rectangle, what's the points, let's say, that you created, how tall it is, or the width, height, and then the draw, how you draw it. So the draw could change, let's say, if now it's a console, but tomorrow you want to put in a Windows program, you want to draw a real square or a real rectangle, then you're changing it for a different reason. The area, the height and width dimensions didn't change at all. So it's changing. So there's two reasons for this class to change. Here's an example that follows this thing. Would be a draw, interface, whatever. It has an area on, looks like the naming is a little off maybe. Okay. So here it has just one thing that you have to implement or inherit. It's the area. So these classes just take care of only one thing, of creating its dimensions, how you would show it, and then you would have a separate thing that and then you would have the draw. This takes care of this class in the bottom, the drawing console class, that would take care of drawing it. So if you would need it now, if you would have to show it now on a Windows app or something else, you would make a separate implementation for this, how you display it. So like the console, you would write those lines, whatever, the people that do all the tricks in the console. I have no clue how they do it. But this is, so basically the shape alone didn't change anything. The class stays the same. It's the same thing, and the console, the things that draws it, is divided. If you have any questions, you can ask. Als versteht nicht etwas, kann man fragen. Ich weiß noch nicht, was das so ist. Okay, the second principle is open-close principle. So the open chest surgery isn't needed when putting on a coat. Also was macht ein kleiner change to that program. Das nicht daran gehen, die Kishkis von dem zu tauschen, the programs. Man darf spawnen als a Weg, was darf sein, you should be able to extend the class behavior without modifying it. So that's one thing, and then in other words, a code should be open to extension. The code should allow you to extend it through inheritance or through other ways, but close to modification. You shouldn't have to go into the source code and make a change in the main class to extend the class.
Overriding a function?
So overriding a function
If a child class overrides a method, that's called modification?
So modification, if you could, like in JavaScript, you could basically change what the base class is. You could change the functionality itself. That's not conforming to open close principle. you could extend it if you, I don't know, you could probably derive from it and change the implementation.
If you derive and you have your own method that overrides the parent method,
You
is
So
that
you-
considered extension or modification?
If you override it, and then it's an extension. But if you override it, the extension. If you override it, then it's
So in other words, if you ever
modifying.
have to go back and
If
tweak
you're going to the
actual
prototype and changing what something does over there, then you're overriding. But it's also in static languages, if you have to go into your code to change a class just because you want to add something, that's violation of this.
So the violation is by modifying, not at the beginning of writing the code.
It should the code alone should protect itself. It should allow you to extend it, but it shouldn't allow you to change it. And you shouldn't make it in a way that you have to change it.
You have to change it for what? Program beta, I would like to see if you add more functionality to the same class.
You could add more functionality, but if you're adding an extension to it, depends what you're doing. And all these principles work in a way together, so it's in single responsibility. A lot of these things you shouldn't have a class that does 50 things. So if you want to add functionality, usually would be extension or another class, another whole another service. So do is product filters. You're given a list of products and you want to filter it by color, let's say. You don't see it? Okay, sorry. Something duplicate.
The idea is it should be modular built rather than.
To be modular build, that's one of the things. So here you have, let's say this is like filter by color. So you build a website and they say you should be able to filter by color. So you make this thing. Next, a few days later, they say they need also by size. You should be able to filter by size. So then you ask them what, by size, by color and by size, or only by size? So they say by color and by size and by size. So that what happens is you go into the code and you add here another few filters. So now this class is starting to grow. So you're modifying the main class for the main filter thing. So you're not extending it. You're adding. It's open. It's open for you for changes, and that's a violation of open close principle. So how do you implement such a thing? So this is a product filter, but here it does something else. Here it filters by something. So it passes in the products like we had before, and now it has a product filter specification. So now this is a base class that goes through the filtering. This is in the main thing, and then everyone that overrides it just takes its thing. So here you would have. It has the check, so it checks if let's say the color filter by color checks the color and returns if it's that color, if it's a filter by, and like that. If you want to add, let's say now by color and size, you would just create another filter specification without changing the main filtering. So you don't have to change this. You could just go and add another one, a filter by size.
So jij doet daar extension van de class.
So extension from the main class, and then in every part it only knows about itself. It takes care about itself. It's not busy with 10 things. So everything is built on the other principles. It's not five separate principles. It's really combining one builds on the other one. You could use it a little separately, but you really gain when you use it all together.
Performance in one big function or separate functions for
I don't think so, but this might let's say it takes a little longer. The computers today are so fast that development cost is more expensive than buying a stronger computer or whatever it is. Just maintaining that big class that has 50 functions is going to cost you a lot more than this small amount of CPU it takes you to run through these classes. So LabDAF gets slower, but
really the compiler should be able to optimize it.
Could be. I can't answer, but it doesn't
No
really.
language. PHP is notorious. PHP has a cost for every function call. A statically typed language costs garbage. The compiler optimizes it.
Okay.
buy
Buy another
no,
server.
stop using PHP.
We had a discussion.
Put it in the cloud.
So what's geschehen? Does it inject state class into the other class? When
So
you call it?
this is, we're not talking about injection, but this is basically you pass in a specification. So somewhere you call this, you're gonna have to decide what you're passing in. But by the main functionality, it doesn't care. It just takes a specification how I should filter
The
it.
specification is the interface?
The specification over here is an abstract class.
No,
Could be an
no,
interface because it has
it has
some
a base
functionality. It has the main function for filtering, and then it gives over the rest to the subclasses. Anyone know how this works, or this is just a bug? Switches the screens back and forth. So this is Liskov substitution principle. So jeder weiß die Sache. If it quacks like if it quacks like a duck, and if it acts like a duck, basically it's a duck. So about the alle JavaScript languages, Ruby, as languages. If it gives you that functionality, then you look at it as its base type, even if it's not specifically the base type, if it's not inheriting from that duck typing. So Liskov substitution principle is that even if it looks like a duck and quacks like a duck, but needs batteries, that means you have to do you're doing some specifics for that specific implementation, then that's a violation of this principle. So derived classes must be substitutable for their base classes. If it derives from a certain base class or interface, if it implements an interface, it shouldn't, let's say, throw different types of exceptions than the main class, or it shouldn't return different data. It has to return the same. It has to return what it's expecting. It has to act like the class that's using it is expecting, not like this needs batteries. This class is different. I'll check beforehand if if this type is like an electric duck, then I'll have to just turn it on. So du hast the violation from the principle. Du hast draw shape that takes a shape, but you're checking like if it's a rectangle, then you're using a separate method to draw the rectangle, or if it's a square, you use a separate method to draw the square. If you have to provide separate functionality for a different implementation, for a different subclass, then that's violating it. You can't just extend it, and if you want to go, then you have to. It's basically also violating the open close principle. If you're going to add now another class, another shape class, you're going to have to go modify this draw class together with it to add the functionality. So here's another thing. We have a rectangle that's a base class, and then we have a subclass that's a square. So you can think of a rectangle and a square is the same. I mean, it has 4 corners, and it should be able to inherit from it. But if a square is always exact, like the same height as width. So what's going to happen over here, if you call on the rectangle test, then you're setting, in the code is setting the height and width, and it expects the height and width to be set how it set it. But if you send in a square, then if you set the height to 10, then the width is also becoming 10, and then you set the width to 20, then the height becomes 20, and you're violating the principle, because it's expecting that it should act the same way as a rectangle, and it's not acting the same way. Understand?
That would be right way.
So the right way over here. So the right way with the square shouldn't be inherited from rectangle. It could be inherited from shape, let's say. You have a wrong way of you abstracting it. You should make a separate thing for shape, and rectangle derives from shape, and square derives from shape. So in that case, you're not expecting height and width to be the same. If you have a rectangle, you expect you're passing in the idea is that you expect you're passing something in, you're going to get a certain result. Here it's not the right expectations. Yeah, there's a wrong abstraction over here.
The drawing class kan toch daarvan checken what type of shape it is, no?
If you're drawing a shape,
The drawing class that you're passing the shape into, when it wants to draw either a rectangle or a square or a circle, whatever, it's still gonna have to check what you passed in before it could draw it, no?
so you would have to, when you implement it, you would have to, let's say in this case height width, but a circle could be differently. It has, let's say, whatever they call, like the corners,
Radius, circumference.
then you have to have some type of, you return a different type that returns all that information, all the point information.
But they're all gonna inherit from shape.
They could inherit from shape
And
because
shape is gonna be passed into the drawing function,
and
and that method is still gonna have to check what type
no,
of
it
shape
shouldn't.
was
It
passed
shouldn't
in
check,
the
because
drawing.
you should return a type that is valid through all the ways.
So what, for example?
You're now violating one rule.
I'm violating a rule, could be.
It's not a cheap shot.
So now let's say the implementation. This would.
So now rectangle is just implementing shape, it's not extending it.
Yeah, because that was a wrong abstraction. It's not.
Okay, so you turn it into an interface instead of an
I mean,
abstract class.
yeah. So here we have basically points. So let's say return with say, whatever, it doesn't, you're not going to draw anything with it. And a circle, you would, let's say, add in more,
A circle can't mishmach with polygonal shapes, it's just a vector shape.
right, so you would add different, this would be an array of vector shapes. Rectangles and squares could be expressed in vector. So you would return it that way. So now it's, I think it still confirms to the first one. I don't know, maybe I'm wrong. Separation of single responsibility principle.
Oh,
It still has single responsibility, and it now derives from shape where it's the right way and not from rectangle that
Yeah, you're right.
and here I would take I shape and now I can't even set height and width over here. I guess the height and width would be set somewhere else.
In order to get the height and width, you'll have to read all the vector points.
No, this class doesn't care about the height and width. It's not supposed to care. That's not someone else has
What's the purpose of this class?
This class? It's a test, I don't know. No purpose. So when whoever's going to create the shape over here, let's say you would over here you would have to pass in the height is 10 and this is 20 to create this shape, or here you would just do one thing. Okay, any questions?
So why does it differ from the first, from the single responsibility principle?
So this is talking
Within the
this is
classes?
this is talking about the requirement for something that derives from a class or implements interface to give the expected whatever is expected to return the expected result, not change the results. Give back a different type of result or whatever it is. If it's expecting this, give it back this, or else you have something wrong going on. It shouldn't be inheriting from this class. You have to probably change the code to a different way how you're doing it now. So interface segregation principle. That's about interfaces. They should be fine-grained. That means they should be small interfaces, not interfaces that do 20 things, or let's say an interface that has to do a few things, but not every type of implementation. Let's say connecting to a database interface. Some database you have to connect to before you call it. Some databases you don't have to connect to. You could just call it directly. If let's say it's a REST database, you just send off your data. So if you're creating a database interface and you do connect, that implementation doesn't have any use for the thing connected. It's just going to be an empty stub. So don't force them to implement something that they don't have to implement. So divide it in a certain way that if not everyone has to implement it, then it's divided.
What's about eine that needs some solid stuff يوم ما connect function. And then how the implementation
So
was the zikr as the guy to ما connect.
Doesn't size separate
you have
implementation.
to have two separate interfaces that you call separately, or whatever you you pass in. Let's say you check if it's that thing by the main part.
A class kan ons bij implementations.
A class.
A class kan ons bij.
The class can implement more than one interface.
A class in C# could inherit from as many interfaces. It could only have one base
It
tag.
inherits from an interface. Does it implement
Implements interface. Can implement as many
I think everywhere
interfaces.
an interface
In
is
C++, I think they have you could inherit from two base classes.
inheritance, yeah, but
No.
implementation. I think everybody lets you implement more than
Right,
one
but inheritance,
Inheritance
some
is
languages allow you, and it looks like it wasn't such a good idea. So clients shouldn't be forced to implement interfaces they don't want to use. That's
There's a whole movement against inheritance bichlal, you know?
against inheritance.
Yeah.
They don't want to let you inherit.
They don't like it. No, there's a whole paper published by Microsoft against inheritance. You should always prefer composition over inheritance. You know what that is? Composition over inheritance. That you inject anything you want, inject it into that
Inject it.
class, then use that class.
You still use instead of base classes, you use
Base classes.
interfaces.
They want to ban to protect protected methods and protected variables, everything. Either private or public.
You could try doing it everywhere. You know, a lot of these methods you do it in the main part of your system, the main domain of your system, and you don't do it everywhere because everywhere is just gonna get you crazy sometimes. If you do it in the main parts, like you wouldn't do it, let's say, in the UI, because UI changes every few years. But if you have your main business logic, that you would try more to implement some of these features. So I don't know if anyone's familiar with the membership provider in .NET. Anyone? No one's familiar with it? That has like
No,
ASP.NET membership provider. It makes you implement like I don't know how many things over here, and you don't have to implement everything for it to work. You could just do whatever you need. And let's say question and answer, you could disable the question and answer thing, so you don't even need this part, or different methods. So this could be split into a few interfaces. So this is one example.
Actual production code that uses a bad interface. Because that's
This
what
is actually Microsoft's code, and a lot of the .NET framework is written like this. So don't get ideas from the .NET framework how to use Solid.
What? Yeah, but once I've got interfaces on the normal.
No, you can't change everything. It's like everyone already uses it.
Session interface.
global functions.
The global functions is back from the PHP 4 era. The interfaces, the built-in interfaces, and the Naya Zachen. The Naya Zachen what you make it allemaal.
So this is another example. You have a iDevice, and it has a draw, and it has an button down, back button down, on menu button. So let's say you have an Android HTC One device. You have a draw that lets you draw something to the screen, and then you have all these buttons, events that are on the screen. But if we would go down to iPhone, then it only has a home button. I don't think it has a back or a menu button. So it doesn't have to implement it. What you wouldn't give it. You would divide this code somewhere else for a device. It's not. You're making the iPhone implement these things that it doesn't have. Something kan shaykhs met them.
Not C-specific implementation.
It's not. It's too specific. It's too many. It's you wanna work for everyone. You should. Fakir, it's too broad. It's not. It's too broad. It's not specific.
Covered C field Zachen. The interface that covers.
So we'll be to cover all devices. Some all features now.
Now interfaces that feels unspecific. That's the difference.
The code to yazan specific. Was nicht specific. So the class alone, every class alone should be specific for its job. That's a single responsibility. That's the main thing. Every class should work only with its thing that it's whatever it's trying to do. But you should have interfaces that allow you to make it not specific. So you're going to program. That's the last thing of.
Als hij zoekt, weet dat programma zal schikken de zelfs van de andere zaad is. He doesn't just pass you the salt. Hij heeft een recht en hij kan implementen een interface. Dus kan hij beschikken alles uit.
What happened over here? I feel like this one can't slide. Clicks. So that comes to the last of the 5 principles when it comes up on the screen. Dependency inversion principle. So he writes over here, would you solder a lamp directly to the electrical wiring in the wall? It's a lamp, it has a plug, it's pluggable. You don't so you don't want depend on abstraction. You want your program should depend on abstract things, not on the concretion, not on the concrete classes. So that's how you make it extendable. That's how you make it. It should be able to work with a lot other parts. Every class alone is close to itself, but the system is pluggable. The system could be used in other ways. Or high level modules should not depend upon low level modules. Both high and low should depend upon abstractions. So the system basically should depend upon abstractions. You shouldn't call new SQL Server repository, because then you're locking yourself into SQL Server. And if you want to ever change it, you're going to have to go into everywhere in the code where you call that and change it, let's say, to MySQL or Oracle or Postgres. MongoDB? No, that's not SQL. It's no SQL. But if you use, if you have a repository, you could do it. Depends on how you query from the repository. It's not RavenDB. RavenDB. No, Mongo.
Exactly, you could use the same repository, the same interface, regardless of whether you use SQL.
You could abstract it such a way. If, let's say, the repository, if you have a way to build the queries, if you're just passing in SQL, you can't pass in SQL to MongoDB. Right, and you shouldn't be writing SQL in your code behind files. This one, dependency inversion principle, basically takes a few of takes the other principles and puts it together. How do you work with such code that you split up in so many classes and so many implementations? How do you ever work with it? What are you going to be doing in your class? So this is order processor. Example of example that doesn't follow the solid. So you would have, let's say, you're passing the order, you get the item total, then you have a discount calculator. So and you have a static method on it that calculates the discount amount. So now if you ever want to change the discount calculator, you decided now I don't want to use this, I want to use something that goes to a special service, new cloud service that decides how much the discount should be. You would have to either change this discount code, or you would have to create a new class and then go over here and change it in every place that you use the discount calculator. And the same thing is over here. You would have, let's say, for taxes, or in Europe they have VAT. You would have to go. You're doing specific code for every single part. You're hard coding everything. So you're depending on concrete code and classes. A good example, I think so, is, let's say, this So here's the order processor with the dependency inversion principle. So basically it takes two interfaces. When you create this class, it takes two interfaces that could be injected by an IOC container. Is anyone familiar with IOC container?
Which one is the IOC container?
Inversion of control container. Dependency injection. So this class, if you want to call it, usually you would have to pass in the what implements the discount calculator, the tax calculator. So there's a the IOC container that helps you out. You register what's going to implement iDiscount calculator in one place in your code, and whenever you create the order processor, it's automatically going to inject that discount calculator. So if you ever decide to use a different implementation, what?
Like a config file?
In a config file,
XML config?
or XML, or in code, or however you decide to configure it.
A mapping.
It's a mapping basically, or you could even do automatically if there's one, let's say one implementation. So in the beginning you do automatically, so it's easier to work, and then you customize. You say instead of this thing passing.
Hard coding domain names and all kinds of stuff. Usually
So you could also hard code information. You could register information into it. Like if I would take here a string. Usually you don't do that. Specific places maybe you would do that. Usually it would be certain implementations. What?
All kinds of hard coding problems, like domain names, API URLs, all kinds of stuff.
So you
A
could
single place to change it.
you could do that, or you could have a special interface that gets that information. A service that gets that custom information. If you're using it a lot of places, because you don't want to go into the IOC container's config and start setting in 5 places domain name. So here you're passing in the interfaces, and then when you do the calculate code, it's basically getting the total, and then it's asking the calculator. It doesn't care who the calculator is. You give me calculate. You could change it whatever you want somewhere else in the program, and it's going to do the calculation.
What's the name again?
IOC. This is dependency inversion principle, or
Actually writes the file and modifies the source code, then you decide it?
no, it's not. That's what's that? Aspect-oriented programming, AOP. That goes through, and let's say logging or other types of things. That's gonna go through your code and add those things. That's like, let's say if you want to add logging to your whole system and you don't want to write log. You don't want to log everywhere through your program, or you want to write certain error handlers. You want to know what's going on, but you don't want to get your whole program dirty with all that information. You would use AOP. But this is more like runtime. Instead of calling order processor, instead of newing it up, you would tell the IOC container, give me an implementation, or give me the order processor, load it up for me, or give me an implementation of a certain, give me an implementation of iTax calculator, and it already knows how to go through the whole tree. That implementation could have 10 implementation that it depends on, that each one could have other interface that it expects. So that's going to build the whole entire tree and give you the ready object that you could use. And the same thing is with tax calculator.
Is it not called a factory method?
In a way, what you call a factory method, the IOC takes care of it. A factory method basically gives you back a ready-made object.
No, factory gives you back a factory based on a condition.
Factory builds the class, builds the object.
No, it gives you back a class based on a condition.
Object.
Right, it builds an object from a class, and it takes care of.
No, you have to instantiate the new object from the return.
A factory method would be over here. Static. this would be
I'm talking about abstract factory. Abstract factory is you don't know which class you want to extend from. So they're returning a class based on a condition. You extend from the return.
not sure. Could be. I'm not sure exactly what you mean, but that's what I call factory class. It's the same gedank, but it's you're not doing that initialization of the class. You're not setting it up. You're letting the IOC container set up that class for you. So
Hallo, dan is de IOC containers wat kan we zijn de new keyword in dat code.
Ze hebben de IOC container. En constructen geen runtime attack.
yeah,
Object, is dat
object.
And the guy to the class, I create the object and inject this into the constructor.
I go to the class. I kick.
To the object instead of grind root to the.
Dus toetsen gaan maken new whatever guys to the calls to the IOC container. En zoek zeg dat voor maar zijn object. So IOC container guide, they kick the object, they kick what's the dependencies to the I guide the dependencies, they resolve the dependencies via the dependencies.
But the object gaat om the same method names out of the guys on the result.
Nein, kicked of the method. Kicked of them. A reflection of that. Gaita dorich the object. Kick wie zij kan es constructen. As
So
kick
it's
do.
resolve the method names and you call später in the code the object and the method names exist. Just add it.
So let's say from the IOC container, you would this is injection. So this constructor injection, this property injection. Constructor injection means that the IOC container is going to inject when you create this class. So if you want to see IOC containers, I could show if someone's interested. So tiny example.
Can you build one?
Can I build an IOC container? Probably
A
not.
very small proof of concept.
No, I'm not gonna do now reflection. Okay. Have to internet abdo. So this is the ISC container, Castle Windsor. There's quite a few in the market. Ich habe nur von dem, so ich werde das nutzen. So the letzte 4, the 3.5 hat MEF and Microsoft. So it's a ISC container. So it does a lot more than ISC container, and it doesn't do everything. So it's made for plugins. Visual Studio's built with MEF, so you could make add-ins, but so let's say what I have over here, public interface. Anyone wants to give an example?
Of an interface?
Yeah, some type of order thing.
Door. Physical object is the easiest to understand. Open, close. A lock would violate
Lock, not every door locks. No? So let's create an implementation for this. Now it's a container. Register. So I would say like this: for door implemented by door. And now
create a house and inject the island.
So over here and in Castle Windsor you have to register every type. So when I create a house, then I have to register the house also if it's concrete. So now it's a container.
It doesn't auto resolve?
No, you can set it up. This configuration you can set up to auto resolve, but I don't know now to check it out. Resolve door, the house. Let's change it over here. So now we can see let's see if first of all if it runs.
How do you inject the islets? How does it know how many to inject?
So it's going to inject all the implementations, I hope so at least. I jump away. I guess it's not working like we need get back into full screen. I'm going to pass in one door, but there's a way to pass in a collection of doors. I don't remember what exactly you have to do. Sorry. We have a door closed. This I just told him to get me a house and he already got the door. So if I add now another implementation,
Slide open.
that. Okay. Makes sense. And then I would just, let's say, register. You can register too if you give an I list, but yeah, you probably have to set something for it. Sliding door. Now the door is sliding closed. So if you use it, this is a small example of an IOC container. But if you use it, let's say with a whole framework, let's say ASP.NET, ASP.NET MVC, or even your own Windows program or any other language you do it, the call comes in. Let's say in ASP.NET MVC, the call comes in automatically, and it tries to open a certain class. So it's not coming in one place. You have to decide which controller to open. The IOC container gets a call, give me an implementation for this and this name. So I could say over here, I can name it, and when I make, let's say, a web call to /house to house, so it checks who do you have that takes care of house, which implementation. So it says, okay, this one. Now load me up this house controller with all the interfaces that it expects, and go through the whole tree and give it back to me. So in the code alone, you're not busy. Your whole code shouldn't look for container. You shouldn't be using container in your code. That should be automatically. In one part in the system, you set it up where it acts as it, but in the whole code, you never call the container. Not never, but usually you don't call the container. You let the container do its work by building up the things automatically. Sometimes you have to use it, but you try not to. Any questions on IOC containers? Understand that works? Yeah, it's a factory. Again, Nick, that's in my presentation. And as I know, Charles can say other comments.
Yeah, what is the line number?